Buonasera, benvenuti a questo nuovo appuntamento con gli Aperitech Online Edition di Codemotion. Questa sera siamo con la community di Deep Learning Italia, come potete vedere Matteo Testi. Io farò una piccola presentazione su che cosa sono gli Aperitech per chi non ci conosce, su che cosa facciamo qui a Codemotion e poi lascerò la parola a Matteo. Come potete vedere, gli Aperitech sono un circuito di eventi organizzato è un'iniziativa di Codemotion, organizzata da Codemotion insieme alle community come quelle di Deep Italia. E come potete vedere qui online potete vedere i nostri riferimenti, abbiamo il canale Telegram, il nostro dev calendar con tutti gli eventi e il nostro gruppo Facebook che vi invito appunto a seguire su Facebook. E che cosa facciamo? La missione di Codemotion appunto è quella di sviluppare, di aiutare gli sviluppatori a una crescita professionale. Questo come lo facciamo? Lo facciamo tramite la nostra piattaforma codemotion.com, tramite eventi, training program, online hackathon, coding challenge, il nostro dev magazine con tanti articoli interessanti e di approfondimento su tematiche appunto tecniche e infine tramite una sezione dedicata alle community come questa. Quindi vi esorto a visitare il sito codemotion.com. Come potete vedere qui a schermo abbiamo i prossimi eventi, ovviamente abbiamo tante community che si occupano di tematiche diverse, da Python a GraphRom a RLady che si occupa del linguaggio R. Quindi vi esorto ancora a seguire il nostro dev calendar e restare aggiornati sui nostri eventi. E per chi ha voglia, per chi ha gli skill necessari, per chi ha tanta volontà di dedicarsi ai sviluppatori e alle community, c'è la possibilità anche sul nostro sito di creare una vostra community su un argomento, oppure se non avete voglia di crearla potete seguire questa o altre community. Vi ricordo la conferenza di Codemotion, l'edizione italiana, che si terrà a marzo, il 23, 24 e 25 di marzo, appunto. Ovviamente anche questa sarà online, visto il periodo che stiamo affrontando. Ovviamente è una conferenza fatta da sviluppatori per sviluppatori, quindi ha già avuto un gran seguito anche negli anni passati, diciamo, le conferenze fisiche e l'anno scorso abbiamo fatto la prima online, quindi vi invito a seguirla. Quest'anno ci saranno appunto, questa edizione avrà tematiche diverse, parleremo dal machine learning al front-end, back-end e si svolgerà in 3 giorni. Quindi ci saranno 5 conferenze e tante tematiche, workshop, qualunque cosa cerchiate sicuramente la troverete. Vi invito appunto ad andare sul sito, sul link codemo.me e registrarvi. E a breve poi avremo ovviamente, seguiteci, avremo anche tantissime novità. Lascio la parola a Matteo. Grazie mille, a dopo.
Grazie. Oh, okay. Hello, everyone. So usually we have a different speaker in our meetups, mostly technical and some kind of use cases from different industry, but a lot attendees ask to have some knowledge from business, in particular from US. So with my pleasure, I have a friend that we know on LinkedIn from a while. Am I right, Alexander?
Yeah, it's been a few years now.
Yeah, a few years. And we receive a different question from where we should study AI, machine learning, why we should move from Europe to US, and how easy or hard is get a job in US. So I'm sure Alexander is the best person to answer this question. So please introduce yourself.
Hi, I'm Alexander Fleiss. I teach at Cornell and I run research for about 5 other schools. I also have a research partnership with the Air Force. I have been intrigued by machine learning for over 20 years, probably 1997, 1998 is when I first started working with Bayesian networks. Originally, Professor Judea Pearl from UCLA. She got me intrigued. But before I get into my story, let's talk AI in the US. Yes, there are a ton of jobs, and not having a citizenship, though, is the only issue. There are places that will have issues with that, but there are also a lot of places that want someone in Europe. So, you know, I think of like a Raven Pack, and they only want someone to be based in Europe, or certain Bitcoin safety firms. The point is that a lot of US companies actually have European operations that they might want you to work for. So that's a potential as well. But I would also, not to get too negative on the citizenship issue, because there's still a huge amount of US jobs that will take a foreigner, and they'll sponsor you as well. I know that the comparable salaries in Italy are significantly lower than in the US, which is a shame, but you know, it's you know, Italy has a very, very well financed educational apparatus, much more so than the US on a per person basis. However, your corporate world has not embraced big data and big data analysis and machine learning techniques the way the US has. At this point, almost every company that can afford to is looking into both big data, or is already using big data, and applying machine learning to their big data, whether it's for customer acquisition, whether it's for their own, well, you know, if they're obviously a hedge fund, trading algorithms, or an algorithm for a travel company. You have to realize that it's being used now from energy, marketing, all over the US. So there's a gigantic variety of jobs in the US for data science and AI. And I would probably recommend that you go to the Russell 2000, which is the 2,000 largest companies in the US after the 1,000 largest, though I would do the 1,000 largest as well. But of those 3,000 largest US companies, I'd probably say 90% are hiring someone in big data science. And you need to go to their website. And, you know,
Ale, sorry, I have
Yeah.
two questions from the attendee. One question is, what is, for your opinion, the best master's degree in AI, machine learning, data science in US? You are a professor too, so maybe some insight from your experience where you
mean
teach.
what schools or what degree? I mean, I don't.
Undergraduate, I think. Give me I don't know, 5. The best 5 for your opinion. You know.
Best 5 schools undergraduate
Yeah.
are
with a master degree in data science, machine learning, AI. For example, I know there is a very good master in New York University in data science. Also,
no, NYU is fine, but it's not one of the best. Absolutely not. No. And my mother-in-law is actually a board member of NYU, so I'm close. My wife goes to NYU. She's actually a student right now. She's getting her master's in real estate, and NYU has a decent real estate school because New York is the wealthiest, you know, real estate city besides like Hong Kong or whatever. Maybe now I think it's more than London, but I think it might be behind Hong Kong. But also Hong Kong just had a big price correction. Johns Hopkins, Carnegie Mellon, Harvard not so much actually. MIT, sure, but there's a big bias against MIT in the U.S. because often there's a lot of arrogance involved with MIT students. And nobody wants to. Arrogance is the number one quality that hirers will want to avoid over anything else. So you know, obviously meanness, but arrogance is just a suicide if you're trying to get a job. You have to be as humble as possible. You need to show your work.
John Hopkins, Cornell, Harvard, MIT, And
I wouldn't say Cornell's one of the top 5. No, I don't think so. I'd say MIT, Johns Hopkins, Carnegie Mellon, Stanford, and that's it. I would say those 4 that,
okay,
off the top of my
okay.
head. But yeah, those 4 are the best.
Other question was, from your point of view, what is the best industry where we should study AI?
Yeah, great question. Healthcare. U.S. healthcare is growing very fast, something like 7% a year. It's the #1 industry to embrace big data and machine learning. Also, you have both biotechnology and insurance. And insurance is gigantic. Humana, United, they have 5,000 and 10,000 person divisions doing data science because their whole business is data science. If you're an insurance company, your business is financial engineering. So that's it. You're taking your customers, you're deciding on your risk, you're deciding on your profit. The whole thing is a risk versus profit. So yes, their whole business is data science. So Humana, United Healthcare, Cigna, just, WellCare, Centene, whatever the large, there's 20, 30, 40 large health insurance firms. They're all hiring, every one of them. And those are probably the first I would look for in terms of I just want a job, because it's easier and they're hiring a lot. #1 more than anything else. I'd say healthcare, insurance, definitely.
And financial service?
No, financial service is, hedge funds are hiring a lot, but it's hard to get a job at hedge funds. It's very tough. Some fintech firms, yeah, fintech somewhat, but banks are generally getting smaller right now. They're not, banks are not a growth area, fortunately. So
okay,
yeah.
so basically healthcare in any of the ways, so biotech,
also energy, oil companies. Oil companies are really hiring a lot of data science people right now, and that's that's a place that's very hot. Cloud companies are expanding right now, and cloud customer service bot companies like Zendesk, is expanding rapidly. So but even the mundane or boring companies are expanding their data science divisions and they're hiring. So it's not it's America is the most embracive of data science and machine learning more than any other place. Ukraine has a ton of jobs. If you don't mind living in Ukraine has the lowest taxes. Might be easier for you to find a job there working for maybe even a US company outsourced in Ukraine. And it's very cheap to live there. Obviously, if you're used to living in Italy, Ukraine's going to be a step down. So I love Italy. I've probably been to Italy 30 times. I had my first kiss on the island of Capri when I was 13 or 14 years old. So
you are half Italian, am I right?
No, not half. 23andMe said I was like 17% Italian, and nothing else was over like 3 or 4%. So Italian is the largest percentage of my 23andMe background. So I really have a tremendous level. I'm actually the only member of my family that does not speak fluent Italian, which is embarrassing. I've got 3 older brothers, a mom and a dad also who speak Italian. I don't. I was born deaf, actually, and I'm also autistic. So learning languages for me is impossible. Just really learning English took 15 years. And so, everybody else who was born in America got to just learn English from hearing their mom and dad as an infant and not have to think about it. I unfortunately had to learn it from scratch. And because of my, autism and deafness, English was very, very tough. Plus, English doesn't make practical sense. Latin makes practical sense. English is not a practical language. It's kind of a stupid language. But anyway, it is. That's why I've been programming since the early '90s, video games, and I got into machine learning in the late '90s when I started getting excited by some papers I was reading. So I remember 97-ish, 96 is when I started coming across Judea Pearl's work. Judea Pearl's a brilliant professor from UCLA, probabilistic AI. I'm trying to get him to come on my show. He's being stubborn. I don't know why. It's annoying, but
I got another question, and this question you usually ask me, my student, to what is the best path in terms of bachelor degree to approach AI, for example, computer science or
definitely computer science, without a doubt. Coding, your raw coding abilities at this point are very, very, very important. The best firms want, pretty coding. So, a good programmer is really important. If you're not a good programmer, it's gonna hurt you in your job search, depending on where you go. But a lot of places, the top places, care about your programming abilities. So let me rephrase that answer, actually. I think for really elite firms like Google, Facebook, or the biggest hedge funds, programming is very important, and they will look at your programming. But if you want to work for not a lesser firm, but different, more like an energy or healthcare, data science can be more important for a lot of other firms, and they're going to care about that. Whereas I think the larger tech companies like Google and Apple don't care about data science. They just want to see your coding abilities and your
programming developer.
Yeah, your programming and your math abilities are the two things they care about. But a lot of companies are just out hungry looking for data scientists in America right now. So just because Facebook does or does not want something doesn't mean that there aren't 10,000 other companies who want, the opposite or something different. So there's the one thing I learned in building Rebellion's learning system. So, we started with a deep learning, but then we found deep learning was a little slow. And so we moved to a reinforced deep learner, which is a little more superficial and is able to pivot quicker, So reinforcement learning is technically much harder to implement. It's tougher, but it also is more superficial though than deep learning. They're different machines for different tasks, which is going back to what is the best. Coding, being a great coder will help you the most for Google, but I don't know if it'll be as important for like a Johnson & Johnson or a gigantic healthcare company like United Healthcare. United Healthcare definitely is a place I'd recommend everyone look. They're hiring like a.
Okay, so computer science for as a background in a university, bachelor, and so on, and industry healthcare. I have another question from your series, your interview you did during this time, because when I share on LinkedIn my interview, I have a lot of comment and message, and the basic question was, you got an interview with a very, very amazing guest. In terms of AI guests, which one is the best, not in terms of technical or prestigious authority, but give some insights that you also thinking about and give some new perspective of AI in the future?
That's a good question. Honestly, the most important person in my life is one of my students 2 years ago who got me to start working on some stuff. So students are so important, but it was good that Jan LeCun kind of agreed with what my thinking was. I guess he's the smartest person I've had on the show. And I liked what he had to say. But that's a good question.
Yeah. Because you just for the audience, if you go into the Facebook page on Rebellion Research, you can follow, you can see a lot video interview from different guests from NSA and AI.
I had one mathematician who came on specifically almost to try to contradict Jan LeCun. Jan LeCun believes that, with gradient descent, you get a very rigid valley, and so you just have all these local minimums. He thinks that Jan LeCun is wrong, and that you have a much smoother valley, and so that's interesting. So I don't know how much I really learned though at the end of the day from the guests. I feel like I don't think I learned a ton from them. It's hard for me to learn when I've been a practitioner for so long, and it's a 20-minute show on techniques, and it's more of like a show about insight, giving ideas for other people out there. And I do get ideas from my guests, very much so. So there's a huge consensus towards reinforcement learning in fixed income. So using reinforcement learning to rate bonds. By the way, also, if people have an idea for a question that comes to them in the middle of the night, you don't have to go to rebellionresearch.com to contact me. You can go to my LinkedIn page, friend me, and I accept everybody's friendship. I respond to every question, and I don't sleep a lot, so.
Okay. Another question for you. What exactly doing Rebellion Research? So it's like a company focused on financial. It's like a blog. This is another question I receive on LinkedIn.
So Rebellion makes our profit from managing clients in 40 countries and managing a hedge fund for institutional larger clients. That's where we make our revenue and our profit. Rebellion spends most of our time, though, putting out smaller notes, large, research pieces, these YouTube chats, that Matteo was kind enough to join. And, we don't derive any revenue or make any money from it. That's just purely educational. So Rebellion is really a binary business of money management and education, machine learning think tank. And you can almost say at this point that our primary business is an educational machine learning think tank funded by our asset management division, which is the truth. So I spend probably 98% of my day on the educational side. I mean, I am a teacher. It's what I like. I built an asset management firm, and now I want to use the asset management firm to fund our research. And so, the publication, by the way, is a great way for people to get their name out there, whether they're an 18-year-old or a 24-year-old, or you're one of the attendees today. If you want to write, 600 to 1,000-word essay on mathematical, data science, machine learning, with some insight, it's a great way for job hirers to be impressed by you, because resumes are all the same. It's without a doubt, resumes are all the same. So, that's actually how Rebellion really got into it. We started having our students publish their work. And so, we've now had the head of data science from Accenture write a piece. We've had lots of professors write pieces, members of the Air Force, Navy. And so, really, pieces are written by 70-year-olds, 17-year-olds, anyone.
Okay. I have a question from my side, but just to remember to the audience, if you want, you can send a message on the chat, and I ask some questions to Alex for you, or pick me on LinkedIn, whatever you want. But I have a question for Alex, because I'm with my team. My team is more focused on education and deep learning Italy, more focused on education and developing AI solution. We are just moving in quantum technology. So what is your opinion in quantum machine learning and quantum technology?
That's a great question. I have a few answers to it. First, I don't know enough personally about quantum computing to give you an honest, intelligent answer. My answer would be based on a summation of other intelligent people. One of my smartest friends is a Caltech guy who is a lot smarter than me. And he thinks quantum is just too fast for finance. And that's something I found when I did a nowcasting project with, Macy's, does everybody know Macy's? They sell stuff in the US, like a clothing store. No? Does nobody know Macy's? They're one of our Thanksgiving Day parade. So I did a project where they gave me their 50 revenue segments by hour. And so I had their hourly revenue segments, and I used nowcasting to try and come up with correlation between their stock and their own revenue. Because Macy's as a company was interested in, can we have insight on our own stock from our own sales? And in fact, no, they could not. There was absolutely no freaking correlation. We had to take their sales data from hourly and make it into like 10-day and 14-day digits. And only then could we come up with some intelligent analysis. So nowcasting is a slower quantum computer, if you will. So if nowcasting is too fast for finance, and what is finance? It's the movement of a lot of people. Think about 1,000 people in one room moving to this side, 1,000 in one room moving to this side. They're all moving to the Tesla side of the room. Now they're moving to the Neo side of the room. And so that takes time for all these investors to move around, which is what finance is. And so nowcasting is like boom, boom. And quantum computing is like zing, zing. So it's too fast for finance. Finance is a bunch of, 40-year-old, men mostly making decisions, kind of in a slow,
But do you think when computing technology will be ready, will be the same impact of AI at the moment? What do you think about?
By the way, is there a way I can see everybody, or I can only see you?
You don't see me?
I only see you. Can I see other people, or no? Are you the only person I can see?
No, the other people can't share the screen. Just doing.
Got it. I was just wondering if I could see all these people, and I have not been saying hello to everybody. So
no.
Good to know.
At the moment, there are mostly 30 people following.
No. I didn't want to be rude. So I just.
No.
It just dawned on me. Because of my autism and my deafness, people can mistake, how I am for being rude. I'm never rude. I'm never mean to anybody. In fact, I give everybody their time. 15-year-olds from Austria who bother me about their programming projects. I, very much don't differentiate. And so I love to teach. It's absolutely my passion. So.
Okay, so guys, if someone have some question from Alexander to
also, if you want to read the book Dark Pools, it's by Scott Patterson, the Wall Street Journal quant reporter, and one of the chapters is on me, so it's fun to read about me, I guess. And Scott, runs the quant section for the Wall Street Journal. The book is called Dark Pools. It's check it out. That's the book right there. So
can you bring it? Okay. And I also see the last interview from Rebellion Research, the mathematics girl. I have written the book Big Data. What is called the last interview you did?
Oh yeah, my friend Irene. Yeah, no, Irene's a good friend of mine actually. Well, we wanted to play that down so that deans across the country would take buying her book for their students more seriously. But yeah, no, Irene's actually one of my best friends. She got me my teaching position at Cornell. And actually our daughters play together. We both have 6-year-old daughters, and they get along great actually. But yeah, no, Irene's super smart. She's we do very different stuff. She's all about high frequency, and
But
big data
she write a book.
Yeah. Big Data Finance. Check out Irene's book, Big Data Finance.
Big data, on Amazon. On Amazon, you can. Okay.
Yeah. But feel free to sign up for Rebellion's. Our blog is it's fun, and obviously it's free, and we lots of interviews. But from space to military, we've had 5 astronauts from NASA come on. I love space. I'm obsessed with space.
I see. So I suggest all audience from Deep Learning Italy to go to the Rebellion Research on Facebook, LinkedIn, or on the website, and following the interview that Alexander did during this time. And you have some news from the next interview.
Hi, Felipe. Good to see you.
Hi, Felipe. So, Alexander, hello. Do you have any news from the next interview you're going to do, Alexander?
My next interview? This week on my so you can go to the fastest way to get my show is on YouTube, which is we just started our YouTube page 2 weeks ago. It has a pathetic 500 subscribers, 400 subscribers. On Facebook, we have 140,000 subscribers, but we didn't do YouTube for whatever mess up, and I hired a new guy who's all on top of it. But tomorrow we have Laurel Toby, who founded Media Bistro, which she sold for $100 million, and now she started her own venture capital firm. And we also have, does everyone know what eVol is? The cars that can fly. We have the CEO of Transcendere, which is one of the more valuable eVol startups, coming on Thursday. On Friday, we have British Petroleum's head of data science, Satan Karakis. Like I was saying, energy's hiring a lot. British Petroleum's hiring a lot. I also have Nikita Fadiv coming on.
Alexander, may I suggest another speaker?
Who?
Felipe.
Oh my God, I'd love Felipe to come on. Whenever Felipe wants. Felipe, can you introduce us over email later today, Matteo?
Yeah, sure. My pleasure.
Wonderful, thank you. I've got my wife is sick, so I've got to go bring her ingredients for chicken soup. So I guess I'll sign off and let Felipe take over.
Yeah. Thank you, Alex, for your time.
Wonderful.
Thank you.
Oh, my pleasure. Thank you for inviting me, Matteo. I appreciate it.
Thank you. Bye.
Bye.
Okay. I hope you enjoyed the conversation between me and Alex. If you have any question, you can write on LinkedIn to Alex. I recommend to follow the Rebellion Research on LinkedIn, because there are very good interview with John Legan and a lot of guests. And so it's a pleasure to introduce the next speaker, Philippe. So as Alexander, we only know on LinkedIn, just for a while, I think 1 year, so most 2 years, I don't know. Just write a couple of messages to give some suggestions, and so please, Philippe, keep going and introduce yourself, and maybe if you want to share your presentation. Thank you.
Yeah, sure. So first of all, thanks for the invitation to talk here. It's a pleasure. I've been following the work of Deep Learning Italia for maybe a year or two, and you always, you always publish a lot of interesting things related to AI, and as I'm also working in a similar field, it's quite beneficial. So I'm just trying to find out how can I share my screen here. Where is the button?
Paolo, can you help us?
Okay.
You share the screen of Felipe.
Okay. We're present.
Nice. So okay, show my screen. Then I'm just trying to find out where I choose which screen. I think I'm on the wrong screen here. Do you know if I can choose which screen I'm going to share? Maybe I'll just unplug my other monitor, and then we'll have everything set. So can you see my screen now?
Yes, yes.
Okay, so I'll just try to present from a single one. Now I think it's, can you see it?
Yes.
Sure. Yeah, so first of all, thank you all for the invitation to talk here. It's my pleasure to be here today. And so Matteo asked me to present what we've been doing in our work related to use cases of machine learning in healthcare. Today I work as a neuroradiologist at the Federal University of São Paulo. And also I'm the head of AI at DASA, which is the 5th largest diagnostic company in the world. It's the major company in Latin America. So first of all, who am I? So I started coding when I was 13, and then I went to med school. I became a radiologist, then neuroradiologist. I did my master's degree in genetics and biotechnology, then my PhD in AI and radiology. Since then, since when I started learning about machine learning, which was about 4 years ago, I really loved it. I started to code and some models, participating in Kaggle, and this led me to be, people noticed what I was doing here, and this company called DASA hired me to be the head of AI there. And most of my research interests were not always related to AI. I mean, first of all, I was very keen on electronics and both digital and analogic electronics, programming microcontrollers like PIC microcontrollers and Arduinos, digital signal processing specifically for medical applications, for medical devices. And after I went to the radiology residency, I started to work also with medical imaging and image processing and computer vision. And this is where AI, machine learning, and deep learning came in. All of those ideas are mainly related to getting research and trying to apply it into clinical practice. So I think this is what excites me at most, which is translating cutting edge research into clinical practice. So I have tried to be active in this field and publishing some papers on radiology and machine learning journals like Radiology AI, like Radiology, Artificial Intelligence, or the main radiology journal. Also the Journal of Digital Imaging, which is a great venue for medical imaging in general and also for AI. We've been working with a lot of different universities, the Universidade Federal de São Paulo in Brazil, and also other companies like DASA and the Brazilian College of Radiologists, the Sociedade Paulista de Radiologia in São Paulo, Brazil, also RSNA, which is the major radiology society all over the world. It's the North America Society of Radiology. SIM, which is the Society for Imaging Informatics, also working with specific researchers at Harvard University, Stanford, and many others, and also working on Kaggle. So Kaggle is, I think this is a very interesting, I don't know how many of you are active on Kaggle. If you do, please stay in contact. I'm always participating in competitions and always looking for people to collaborate in competitions. So I just wanted to state that as well. So my current focus is on AI for medical imaging. And we know that AI for medical imaging is not a single person job. It's a job, it's like a team sport. You need people with very different background to work together in this interdisciplinary area. So we do need someone with the medical profession domain and someone with the computer science or engineer domain. And these are the two sides of the same coin, and I'm in the first side of this coin, but we also need people in the other side. So this is the way I see, this is the way Professor Ogier Marques in Florida stated about it, and I completely agree with him. So most of what we have seen today, I know this is not new for you. I assume this audience is already seasoned with machine learning, so I didn't delve into the details of specific architectures and things like that. I'm just giving an overview in how it relates to healthcare. So what we've seen is that after Alex published his paper in 2012, showing how to implement AlexNet in a GPU, we've seen an explosion of papers showing how deep learning could be better than classic machine learning algorithms. And that is usually true if we're dealing with a huge amount of data. If we have a very small set of data, maybe a classic machine learning model will work better. But if we have access to a lot of annotated data, then deep learning starts to work better, usually. I mean, I'm not saying this is always true, but it works in most of the cases. And so we have these models that when we have a lot of data, we're able to make them work better. But to train these models, we need a lot of computer computation. And we've also seen in the recent years, since 2006, a gap in the computer power of GPUs when we compare to CPUs. So GPUs here are in green and GPUs are in blue. And this graph stopped in 2014, and we know that this has kept growing more and more. But the thing is, GPUs are able to do a lot more computation. And just to illustrate this, maybe some of you have already seen this video from the guys from Mythbuster. And they try to compare how a CPU works and how a GPU works. So a CPU like your AMD CPU or your Intel CPU, it usually makes one calculation at a time. Maybe not one, but just a few calculations at a time. And you can make that faster by accelerating the clock of the CPU, but it's like a gun with a single shot per time. You can do a lot of things like printing this smile, giving one shot at a time. It will take some time to do that, but when you compare that to what a GPU is, which is a parallel unit of processing, you have like hundreds of or thousands of computations at a single clock, and then you can print the entire image that you want, maybe much more complex image in a fraction of the time. So this is how we were able to make all of those deep learning algorithms feasible to be trained with a lot of data. Otherwise, it would take a lot of time to do that. If there's someone here in the audience who is not used to coding and creating neural networks, I think this website, the Google TensorFlow Playground, is a very interesting visualization of how a simple neural network works. And you can choose the features in the input, the number of layers in your neural network, and the number of neurons in each layer. You can choose your learning rate, your activation functions, and the data that you're trying to fit. And then you can try to train your models and change all these hyperparameters and try to make your model fit and not overfit. It's quite interesting, especially when you're beginning to study these concepts. This is one example of a neural network that was trained here in a university in Brazil. This specific in the Universidade Federal de Goiás, It was created by some students of the Deep Learning Brazil community. I don't know if you guys have already talked to each other. Professor Anderson Soares is the professor who leads Deep Learning Brazil with a lot of students. And this is one of the applications they created. They have a face detection that tells if a person is male or female and what kind of sentiment this person is exhibiting, if the person is nervous, angry, or happy. And so this may have a lot of applications in a lot of industries. This is just a way to show how we can use deep learning in a lot of different applications and scenarios. People have trained specific neural networks called style GANs, which are able to do what you're seeing here. You're able to create people that don't exist and also make transitions between the faces of those people. The possible applications of deep learning seem endless today. Self-driving cars are very easy to understand. They are a very natural application of deep learning. And this is why a lot of researchers in this field, including Professor Andrew Ng from Stanford, say that artificial intelligence is the new electricity, because electricity itself is boring, but what electricity opens as possibilities for us. Imagine if you didn't have television or electric light or computers, or I mean, there's a lot of things. Maybe refrigerators. Imagine if we didn't have a refrigerator to store your food and make it last longer. So electricity by itself, it's boring, but the whole applications that it makes possible is the point. And this is what he says about artificial intelligence. This is the reason why many of these huge companies are so interested in AI, and also the smaller companies as well, so most of these startups. So I've talked too much about AI in general and how it's the interest in AI has grown. And now I'm going to focus on what I came here today to talk about, which is the use cases of artificial intelligence, machine learning in medical imaging and other applications in medicine. So this is a paper in this scientific reports, a journal from Nature, that showed that they were able to use the information from clinical information from patients together with the imaging information from magnetic resonance imaging, or MRI, and they were able to predict how long the patient would survive with a brain tumor. At first, it doesn't seem something interesting, but one question that we get from patients with these kinds of diseases is how long I'm going to survive. A lot of patients ask that, and we don't have a crystal ball. It's very difficult to predict all the possible factors that may influence how long a person is going to live with a serious disease like this. And these models were able to narrow a lot the error in this prediction. So you're able to give a patient a much more precise estimation of how long they're going to live using this kind of model. So this is one application that changes the way we work today. If we are able to validate these models and make sure they really work, and we deploy those models in clinical practice, this is something that can change the way we do our clinical practice today. Another application that is much more maybe natural, and people have seen a lot of these applications, is to use medical imaging, in this case, mammograms. Mammograms are like X-rays of the breast, and we use that to try to do screening for breast cancer and try to diagnose breast cancer in an early stage when it's still curable. And people have trained, and many companies have done that. Many other papers have come after this one, trying to diagnose cancer from the mammogram. And they have very, very high performance in most of all of these papers. And it doesn't end in the medical imaging world. People are also starting to apply AI in surgeries. So this is a work that was conducted in this hospital, the Massachusetts General Hospital in Harvard, by Daniel Hashimoto. And what they did was they already recorded many of the surgeries they did. They had these videos, and they also had the annotation for which step of the surgery was happening at each specific time during the video. So they trained this model that was able to make a fingerprint of the evolution of the surgery during time. So they were able to know and quantify in which step the surgeon was during the procedure. And this is important because if something goes wrong during the surgery, the surgeon may change steps or skip steps or go back in other steps. And this changes the evolution of this fingerprint. And this is a signal that something is wrong. And this is a quite interesting application of AI outside medical imaging and during real world operation in a patient. Another very interesting application, in my opinion, is related to this statement. So imagine a person telling you that he or she is embarrassed to tell that because this person is seeing a robot therapist, not a person, I mean, not a real person therapist. And this was work done in Stanford as well, where they leveraged this chatbot they called WowiBot that was created by Professor Andrew Ng as well and his students. And they showed that people who used the bot had a lower depression and anxiety than the other students who did not use this WowiBot. And this was quite surprising for me because it's like you're putting people to talk to robots, and the robots are actually helping people get better from their depression or anxiety. And then we come back to medical imaging again, where maybe most of the applications are exploding today. And this is an interesting one where, so just to give you a little bit of context, if you're not from a medical background, diagnosing Alzheimer's disease from an MRI or from a CT is quite difficult to do. There are some patients who have signs, very specific signs that you can be pretty sure they have Alzheimer's disease from the MRI. But most of the patients, this is not the case. It's quite difficult to know the exact diagnosis of a dementia. And these researchers used nuclear medicine using an exam called PET, which is positron emitting tomography. And they leveraged also a deep learning model to interpret the images from the PET. And they were able actually to predict if a patient would have Alzheimer's or not in a year or in 5 years from that time. So they were able to know in advance, before the patient had any symptoms, if they would develop Alzheimer's disease or not. And this is something that also changes medical practice if we are able to validate these models and deploy them. Another great application, which is not related to radiology, but to cardiology, another work done by Professor Andrew Ng and his students, they were able to diagnose the most common arrhythmias, cardiac arrhythmias using deep learning as well. So reading this signal from this electrical signal from the heart, they were able to diagnose most of the common arrhythmias with the same degree of certainty as senior cardiologists. And then people were, at the time this was published, people were wondering how could we use this? Because if it gets it right in the same level as senior cardiologists, why wouldn't we just ask the cardiologists themselves? But the thing is, you don't have a senior cardiologist everywhere in the world to see all the patients that need a cardiologist. So these models could be used to deliver this high quality care and diagnosis in places where people don't have access to a senior cardiologist. Maybe the most shocking application was this one here that I found recently. This one was published in JAMA, which is a very renowned journal in medicine. I don't know how many of you have a medical background, but what I'm going to explain here is something that seems like sorcery, because what they did was they got a video from the face of some patients, and with a few seconds of video, they were able to know if this patient had a specific type of arrhythmia called atrial fibrillation. This is the most common arrhythmia. And this is shocking because this is an information that is not available for us. At least I don't know any doctor who is able to look at the face of a patient for a few seconds and tell, okay, you have atrial fibrillation. This is something that we need to do a specific examination, listen to the heart with a stethoscope, or feel the pulsation at the wrist of the patient for a few seconds. It's not something that we can see in the face of the patients, and these deep learning models were able to diagnose atrial fibrillation from the video of the face of the patients. So this is something quite shocking for me, and it shows a whole new world of possibilities that AI can bring to medicine. I would just state that although I'm telling you a lot of exciting and new applications, you may have noticed that for most of them, I always say that we need, if we are able to validate them and deploy them in clinical practice, because clinical validation of these tools is something quite hard to be done. So it doesn't seem to work if you just have your data set, a public data set, and then you train a model, and then I'm going to change healthcare. It's not the way it works, because there's a lot of other steps after validation, like getting regulatory approval. In the US, it's the FDA. In Brazil, it's called Anvisa. In Europe, it's called CE mark. So we do need all that regulatory approval. You have to have a very good business model to go ahead. So I'm just saying that although I'm telling you things that are exciting, they're not the solution for everything yet. We still have a lot of work to do. This was another paper by Google. In this paper, they were able to predict which patients would develop kidney disease from diabetes. And this is not a problem. This problem is not solved yet, but they were able to create this model that was pretty good in knowing which patients would develop kidney disease and which were not. This is quite important because kidney disease is something that can reduce the quality of life of the person who has it, and it has also a huge cost in terms of public health. I just wanted to show you one example of a model we created at DASA. This model gets a CT scan of the lungs and quantifies the ground glass opacities and consolidations. Don't worry about those terms. Those are findings of a patient who has COVID. So with this model, I know a lot of other people have done similar work. Also in Italy, I've seen very nice papers from Italy doing this, and other places in the world as well. But we also did our own model that quantifies the normal lung and the lung that is damaged by COVID. So this is an example of a case that has a lung that is almost normal, very few consolidations and very few ground glass opacities. And this is another example of the same model, but applied to a different patient. And in this case, we see that this patient has less than 10% of the two lungs that are normal. More than 90% of these two lungs are damaged by COVID. Just to show you an example of how we can use AI to help to quantify the lung damage. And the importance about quantifying lung damage is that this damage is related to survival. So we can predict how long a patient will survive, if this patient is going to die or not, if this patient is going to need an ICU bed, if this patient is going to need intubation, if this patient is going to need to be hospitalized, or if he or she can be treated at home. And this is why it's important to quantify precisely how much of the lungs is damaged. I just wanted, we're reaching the end of this presentation. I just wanted to give a shout out to some institutions that have created machine learning challenges on Kaggle and also on the Grand Challenge platform in the usually created in the MICAI conference. So this is the RSNA STR pulmonary embolism detection. It's a set of more than 12,000 CT scans of the lungs to give people the opportunity to create models to diagnose pulmonary embolism, which is a very dangerous disease. RSNA also had the intracranial hemorrhage detection. This is computed tomography of the head, and they have also thousands of cases with all types of hemorrhage in the head. RSNA has also done the pneumonia detection challenge in chest X-rays. The SIM ACR pneumothorax segmentation challenge, also another very important disease that is diagnosed in the chest X-rays as well. So there are many Kaggle challenges related to medical imaging, related to medicine in general, and I invite you all to participate if you have never participated in any. I just wanted to finish. This is an editorial in the Radiology AI journal from RSNA, where Kurt Langlotz, radiologist from Stanford, asks, will AI replace radiologists? After seeing all these applications, it's natural to think radiologists will be replaced by AI. But this is not what Kurt thinks, and this is not what a lot of radiologists who work with AI think. The main idea in this, in his editorial, is that radiologists who use AI may replace those who don't use AI. So it's a different question, and it's true, I think, in my opinion, because AI is not ready. Today we have thousands of applications of artificial narrow intelligence. We don't have artificial general intelligence yet. So it's almost impossible to replace all the tasks that a radiologist does. One of the tasks that a radiologist does in a clinical daily basis is look at an image and make a diagnosis. But this is not everything. So AI is only able to do a tiny part of the entire job. So this is why we think AI will not replace radiologists. But radiologists who use AI may become more efficient, work faster, make less mistakes. and this is the reason we think radiologists who use AI may replace those who don't. And you can try to extrapolate this idea to medicine in general. I'm just saying radiologists because radiology was the first specialty in medicine to be overflowed by AI applications. This is an example of a Telegram bot that uses the bone age model we built for the RSNA challenge in 2017. This model was created with the Universidade Federal de Goiás, the engineers from Goiás in Brazil. And what we did here, we deployed this model in a Telegram bot, so you can use Telegram to take a picture of a hand and wrist radiography, and then the model will run its engine and do the inference and tell you what age this person would have if it was a female or if it was a male patient. And it also gives you an information related to where in the image the model was looking at using GradCam. You may be familiar with GradCam to show the person why the model chose that specific age. And here we go. Here we'll have the image of this heat map showing the places that were more important to say that this is a 13-year-old male or a 14-year-old female. And just to finish, I don't know if you have heard about this website. For those of you who don't code, Teachable Machine is a website from Google where you can upload your own images and train your own neural networks without the need to code. And if you do code, you can even use Teachable Machine as well, and you can export your models as TensorFlow objects or Keras objects in the end after you do the training. If you want to do a very simple demo for someone, you can use this website. It has great visualizations, and you can use the model in the end. You just plug it into your pipeline if you use Keras or TensorFlow. So this is mostly everything I had to say. I don't know if you have any questions or comments, or I mean, I'm here available to talk to.
I already have a question for you.
Nice.
From the audience. Which are the implementation for privacy of deep learning, looking for your example on atrial fibrillation detection from video?
This is a very nice question, and it's a quite recent concern we've been having. So we know we have HIPAA in the United States. We have GDPR in Europe. Brazil has just approved last year our data protection law, which is quite similar to the GDPR. I think they have read GDPR and make some minor adjustments to make it work in Brazil. So this is a very serious concern, and this is something that we have thought a lot about at DASA, where we develop our own algorithms. We have lawyers who are specialized in this part, and they tell us what we can do and what we cannot. For this specific paper, this was not, so I didn't participate in this. I wish I did, but I didn't participate in this atrial fibrillation paper. I don't know how they deal with it, because they need the information from the face of the patients to make the diagnosis. So, and they even put the image of those patients in the paper that they published. Anyone can go there and download it. So I know they may have found a way to solve this privacy issue. Maybe the patients have gave their consent to appear, to have their photos appearing. But the way it usually works for research in medicine in general, even before we had AI, we always have to apply for the institution review board, the IRB of each institution. In Brazil, we call it ethics committee. And this is an isolated committee of other people who evaluate your research, and they tell you if it's ethical or not. if the benefits it may create are greater than the harm they may create for the patients. And they usually take care of those anonymization, de-identification issues. So this is something that has always been done for medical research in general. And with AI, it's not different. The only difference is that for AI, you need hundreds or thousands of cases. And for classic medical research, we may usually have a few cases or maybe dozens of cases. So this is something that we always did in terms of privacy, but now it's more important because we're dealing with much more data. If you have a data leak, there are more patients who are going to be exposed than before. So this is why there's also this concern with IT security in terms of trying to create the most secure IT infrastructure where you're going to train those models, and you always train them on de-identified data. I didn't answer your question, I know, because I didn't participate in that specific paper, so I don't know how they deal with it, but I think they got the consent from the patients to show their faces.
Okay, thank you. I have another question. The limit to training a neural network, as you said, in the amount of data, and the data in the healthcare field is most of the time protected by privacy. So how it's possible to get this data public or not to the training a good model, like the model used to training the COVID classification?
So that's
the big problem is the privacy to get data, you know?
Exactly, yeah. So privacy is really a big hurdle in healthcare applications in general, and especially if you need tons of data, like to train machine learning models. So I would give you, there are two possible ways you can follow to get data to train your own models. One of them may be easier, which is joining Kaggle competitions to get access to high quality annotated data. I know RSNA has done some of these challenges. I've also participated in the organization of last year's challenge, which was on pulmonary embolism. So every year, almost every year, RSNA is making public a huge data set that is annotated by experts in the field, and it's also de-identified. So RSNA is a big institution that is able to put together data from many places around the globe, and this is important because you have data that has differences because of the differences in the population, because of the differences in the scanners that acquire those images. And so this is one way to go. I showed here some of the Kaggle competitions, the pulmonary embolism one, the intracranial hemorrhage one, the pneumonia with x-rays, the pneumothorax one, and there are many others. If you go in the Grand Challenge, Challenge website, there are many medical imaging challenges, most of them created during the MICAI conference in the past, say, 10 years. So I think these are places where you can find good and annotated data. The other way you can go is to partner with a specific institution that is interested in developing a specific AI model. So if you get in touch with institutions, say, maybe in Italy, you can find a lot of universities where the radiology departments or the pathology departments want to create AI models to increase their efficiency or the quality of their workflow. And they would be able to give you, after they apply for an IRB and do a medical research, they would be able to get access to images or medical healthcare data, de-identify those data, and give you access so you can create those models. So I see those two different possibilities. And also, you asked about the COVID one. So RSNA has launched it's called Record. It was published in the Radiology Journal. It's a public data set of COVID patients. They have around 1,000 chest X-rays of COVID patients and patients who don't have COVID, and also around more than 100 cases of CTs, computer tomographies, of patients with COVID as well, with annotations, with segmentations on each slice of the CT, showing where there is ground glass or consolidation, which is the damage that COVID does in the lungs.
Felipe, may I can add another way to solve the problem of data is using synthetic data.
Very nice.
Or this is the new age of synthetic data. So basically, you can have a bunch of data and create data to anonymizing this data and have the same distribution of the basic data. And also, you can, for the audience, using a basic algorithm called the augmentation. So if I have one image from my lung cancer, I can move this image in different way to create from one image 100 image, you know?
Yeah, perfect. I think that it's good that you brought that up, because I was forgetting about that possibility. So if you have already data set, a specific data set with annotations, you're able to create your own data from this one by creating your own generative model. So you can basically use again and create thousands more images with the same distribution as you said. And you can use those to train specific classifier. I think there's a paper, I don't remember exactly which was this paper, but I think there's this paper where they have, say, 10,000 chest X-rays, and they leveraged, again, to generate thousands more. And then this bigger data set, they used it to train their models, and that model was better than the one trained in the smaller real data set.
Usually, this kind of techniques using a GAN, so synthetic data, are used very often on genetics problem. There is very difficult to find data in folding, protect, or genomics problem or something like that. So you can also solve the problem to the data with transfer learning. So basically, if you try to detect a lung cancer, you can move the model from lung cancer to another cancer, and basically some pattern help the model to classify a different cancer. So, you know.
Yeah, perfect. Yeah, transfer learning is, you know what about transfer learning? I completely agree with you. And the models usually converge faster, or you get better accuracies in the end. And one thing that we've seen, and is counterintuitive in my opinion, but it works, is that if you have the same architecture, one of them you're training from scratch, and the other one was pre-trained on ImageNet. Usually the one pre-trained on ImageNet does better than the one from scratch when you're training for medical imaging. And ImageNet is not medical imaging, it's natural photographs. Yeah. So this is why it's a little bit surprising for me, but empirically people have shown that it works better than training from scratch.
Yeah, okay. I have another question for you. What do you think of the AI voice-based model for detecting COVID infection?
Yeah, that's a good one. I think this was a paper.
I have also my opinion.
Yeah, so I didn't read the paper, so I don't know if I'm able to give you a precise judgment of the quality of that work. Coming from MIT, I think they wouldn't do something that didn't use best practices. Yeah, but I mean, the issue is that the sound a person does when the person coughs. It's you may have that kind of information there, but I just don't know. I'm a little bit skeptical about it.
Bias inside, for my opinion. I wrote the paper, so I'm not particularly agree with this kind of analysis. So it should be better using image to detect the COVID-19.
Yeah, you know, it's always a little bit suspicious when people use a signal that you don't know if the information is there.
Yeah.
You know what I'm talking about. Let's say we want to know if an elevator has people inside or not. So if you take a picture of the elevator from the outside with the doors closed, how can you know that? And if you train a classifier, people have shown if you scramble all the labels in ImageNet and train a model, it performs very well. So maybe you're just overfitting, you know, the information is not there.
Yeah. So I have another question for you, but to be honest, I don't understand. Following the question about privacy, can a model be trained using differential privacy methods?
Yes, you can do that. So differential privacy is a little bit more complex, but you can use it. What I've seen people doing, and I've also participated with NVIDIA in 2 of those experiments, is using federated learning. So you may have already heard about federated learning. The thing is, you don't get data from each country, centralize it in a server, and train your model there. You don't do that. This is the classic way we do it. But with federated learning, each institution holds its own data within their own firewall. The data doesn't go out of the institution. What we do is we get the model, the architecture, the weights, you send to the first institution, you train a few epochs or a few batches there, then you send those weights to the other institution, you train a few batches there, then to the other one, then to the other one. So it's similar if you had all the data together. So this is federated learning. The thing is, people may say that even by doing that, the gradients that you use to update the weights, they may carry information about the data you have, and they actually do. I think this is already, I mean, trying to find out which data you have by using the gradients, I think this is very hard to do. Maybe we are worrying about the overpopulation in Mars, like Andrew Yang says. But what people do is use differential privacy, which is injecting a little bit of noise in the gradients. So you don't have a model that is as accurate as it could be. It's a little bit less accurate in the end, but you scramble a little bit the information that came from each of those sites, and then it makes it even harder to find out the distribution of data from each site. So yeah, I haven't seen people using differential privacy in practice yet, but federated learning is already something that we did. We did a model, we created a model with NVIDIA, with the American College of Radiologists, with the Ohio State University, Harvard Medical School, DASA, to create a breast density model, a model that predicts how dense the breast is in the mammogram for women. And we also did another federated learning, which I get in my knowledge, it was the bigger federated learning experiment in the world. It was led by NVIDIA, and it counted with 20 different hospitals all around the world, and none of them shared data. In all of them, data was kept inside the firewalls. And we were able to create, in this case, a model that predicts if a patient with COVID will need to be hospitalized or not.
Okay, other question. How much difference in getting medical image in different hospitals and target population bias may affect the replicability of the training of deep learning?
Yes, this is another great question, and this is
So
something
this is sorry, this is the question about when you put the model in the real world, doesn't work.
exactly. So at DASA, we have tested models from different companies all around the world. We have also created our own models. Last year, we deployed, the year before that, we deployed 14 models. Last year, we deployed 12 more. And we are always testing those models. And what we see is that people who train their models with images from a single manufacturer, let's say you only have images from Philips or only from GE or only from Toshiba or only from Siemens, usually these models don't work in images from the other vendors. So this is a thing. It really happens mostly for CT and MRI scanners. For X-rays, it usually generalizes very well, regardless of the manufacturer. We have seen that happening, but for CT and for MRI, it's quite sensitive to the manufacturer. It's always sensitive to the population. So if you use the same scanner, but images from Brazilian people, images from Chinese people, the model created in one country may not work in the other one. We see that a lot. So what these big companies, AI companies or startups are doing, they are gathering data sets from all around the world, from different vendors, from different populations with different diseases, and only these kinds of heterogeneous data sets are able to create reliable, robust, and generalizable models. And this is what RSNA is also trying to do in their Kaggle challenges. They are creating huge data sets with high quality annotations and with data that came from different countries. Last RSNA, we had data from Turkey, Canada, US, and Brazil. And if you know someone in Italy who wants to share data in those terms, anonymized data for these challenges, I invite you to do so and tell me, and then we can make even better data sets from now on.
Yeah. We also working on this area as Deep Learning Italy, so we developing a solution to cancer detection, and we are moving to genetics. So we know
that's nice.
we are trying to building a marketplace in synthetics data, to help to the community to developing new AI models,
Well, that's a new idea. I haven't seen anyone creating a marketplace for synthetic data. I'm quite interested in knowing that. Please let me know how you are doing. Maybe I'm going to be one of the users of your marketplace.
Or the partner.
Or the partner. Yeah, maybe the partner.
Yeah. You have a lot. So our last question for you. Okay, do you think that increasing post-traumatic stress caused by COVID damage experience to the better detection with AI?
I don't think I got the question. So post-traumatic
stress caused by COVID.
Caused by COVID. Okay.
Can be detected better with AI. What do you think about?
Okay. That's an interesting question. I haven't seen anyone asking about that, but so post-traumatic stress is mostly a psychological illness. So a psychological illness would,
I think,
how could we diagnose it? Maybe if we use some kind of wearables to get signal from body language, from accelerators on wristbands, or
AAG, something like that,
or AAG, or even from oximeter information. I have seen some other applications. They were not for post-traumatic stress, but they were for other kinds of illnesses, and they were able to know what to diagnose things by. If you have a band wrist that measures the acceleration, you know how the person's hand is moving during the entire day. And this is an expression of what the person is feeling or what the person is doing. And in some sense, this captures information about the mental status of a person. So this may be a good input to use to give an AI model and try to train an AI model. And it's a quite interesting question. I haven't thought about it.
Wow. So this was the last question. Please, if you have any question, you can, I think, write directly to Philippe on LinkedIn.
Yes, sure.
And well, that's. Let me open the camera. So thank you, Philippe, for your time, for your speech. And I let you know from my idea from the marketplace from synthetic data.
Very nice.
We are looking for partners, so maybe you are interested in involved in this project.
Yeah, sure. So the data sets that we are contributing to RSNA are from the University of São Paulo, Federal University of São Paulo, where I work. And we are developing other data sets, and maybe we can do a project together that could be used
we apply a different Horizon 2020, you know, the Horizon founding, you know, the project from Europe, with different call in terms of omics data, you know, and omics data like proteomics, genomics, transcriptomics are very difficult to find. So we find a lot of paper try to solve this problem with AI, but without data. So we think, well, why we don't create an AI synthetics algorithm that can help to create this data set and help the researcher? Because, you know, AI was growing for two reasons: computing and data, but sharing of data. So this is basically the idea. So I was thinking to get in touch with you if you are interested to be involved in some way in this project.
Definitely.
I'll let you know.
I'm quite interested. And thank you very much for inviting me to talk here. I've always followed the work you all do in deep learning in Italia. And I'm a fan of yours. And it's nice to talk here to all of you. And maybe we get to collaborate together.
Yeah, sure. I'll let you know, because we are moving fast to get some idea and project. So I'll let you know about this new project. So
terrific.
Yeah, thank you, Philippe, for your time. And I don't know what time is it in São Paulo?
It's 4 p.m.
Okay, so in Italy it's 8 p.m. So thank you, CodeMotion, for
thank you a lot.
And bye bye to all. Bye.
Bye.
Bye.